never been told I'm
All right, guys.
ever.
So, as you can tell by our title, we are going to talk all about transformations. So, to get started off, we're going to look at some logos, and we're going to kind of take a few minutes to look at what transformations are taking place, what do you guys notice, and just what are some things that separate the different logos from one another, or the different iterations. So if you guys want to take a look at this first one, who here knows what that logo is? All of you middle school students.
I don't know, Mr.
Never seen
I
I
forget your
think
last
it's
name.
the BGSU logo.
So just take some time to
Yeah.
kind of look at the transformations that are taking place and see if you notice anything or
Yeah.
any differences, similarities.
What stands out to you?
Think to yourself for a few minutes. You can gather with your partner and talk about some things.
Is that flipping everything? I can do it. I'll send her. All right.
Because I think if you go from the side of the curve, you're just.
Because I was just thinking about
Yeah, this is from.
All right. Well, you guys give us some time to think about it? All right. What do you guys notice?
the first two after the first one are the logo on its side,
Okay.
and then the logo on its side the other way.
Okay. One is size.
So what kind of transformation do you think got that logo on its side?
Oh, it looks like it was rotated.
Rotated. Anything else you guys noticed? That was it.
Okay, the last one is upside down.
Okay.
Alright, interesting.
All right. Next one.
So go ahead and think about these for a few minutes, and then we'll talk for a few minutes.
What grade are you in?
Eighth grade.
Eighth.
So yeah, she didn't know that.
I know.
Yeah. You know the transformations, right? You're going into this lesson knowing about the major properties.
That's what I thought.
Starbucks does keep getting bigger. There's truth in our song. There's truth in this series.
It takes over your life. Like I saw it and I was like, oh wow, I'm gonna go to Starbucks later.
So since everybody in here loves Starbucks so much, we thought this would be a fun logo to do. So what did you guys notice about this one? Yes, Josh?
I saw that the Starbucks logo just keeps getting bigger.
Okay.
So what could we say that's what's happening? What kind of transformation would you say is getting bigger?
Dilation.
Dilation, nice, good job. Do you guys notice anything else that's going on? No. So what about like the size of the circles or anything? What do you notice about that?
Which,
Think about some of the properties of a circle.
like the radius increasing, is that what you're asking?
Okay. Radius.
Something with the radius, so like the radius is bigger. on some.
And so would be like the circumference
Okay.
and the area, stuff like that.
All right, interesting. So there's circumferences and areas are different. Alright, I like those ideas. See if we can use those in the next one.
Sounds good. All right. So lastly, we have the Google logo, and we have 4 distinct representations. So if you guys want to take a little bit, collaborate with your partner. Obviously, there's several different differences, and so get your thoughts out there, and we'll get back together in a minute.
You pretty much covered all of
What
it.
are you guys thinking?
So, sorry, for your first one is your original one, the top right would be a rotation,
Okay.
and your bottom left would be just reflected over that line that's between them.
Okay.
And then the last one is, also a dilation.
Okay.
I have a question.
Yes, Amber.
When we're saying like a rotation by like if you say that the second picture was rotated by 90 degrees,
Mhm.
is that right? Like are we going clockwise?
Yeah.
Clockwise rotations.
Modern as that's what.
I know, it's clockwise.
Yeah.
Yeah,
you're just-
our stipulation in the class would be, everything will be clockwise.
Mm.
Thank God.
Thanks for bringing it.
Okay. You guys feel like you got everything? What do you guys notice? There's a little more than one thing to unpack here, so what do you guys think?
You can even think about the sense of like which one doesn't really seem like it belongs.
Yeah.
Okay.
So if you think about the noticings in that way.
So we thought the bottom left-hand corner is a reflection,
Okay.
but I guess about the x-axis.
Mhm.
Yeah, I like your preciseness. Anything else? I see something that really stands out to me, but I don't know about you guys.
Well, the one in the bottom right is smaller.
Okay.
It's like dilated.
Dilated. So you're saying it's the only one that
Yeah,
has some sort of size change? Okay.
yeah.
Just put a star by that one because it has a size change. All right. So we're thinking about size and shape here.
Mhm.
And then-
Interesting.
And any other transformations we haven't addressed yet in this one?
Then the top right one is rotated about 90 degrees.
Okay.
All right.
Sounds great.
Cool. I think we got some
Yeah.
good thoughts going on here, but
Yeah.
you guys kind of really hit on all the sequences of transformations
Yeah.
and kind of started exploring some ideas further. And you kind of, I guess, hit on the base that all these sequences of transformations really do affect what
Yeah.
image we have. So I think we should explore that further. So what I'm going to have you guys do is get out your laptops or your Chromebooks, and we're going to kind of go through an exploration.
All right.
Over here. I think they're ones on top.
Yep.
So what we're gonna be doing on this exploration is kind of just furthering what we did in that motivation activity, kind of get you guys thinking about transformations and kind of engage in what we're doing. So what we're gonna do is Josh is handing out the handout that we're gonna do with this exploration, and you're gonna go to the applet that's on there. It's a Forest Hills GeoGebra, so that kind of helps find that application easier. And you're going to pay attention to what's really happening. It's like a letter F. But with that letter F, you can do various transformations with it. And I want you to pay special attention to some of the special properties that are going on with that. Think to yourself first, see what's going on, and then you can kind of correlate with your partner and collaborate and think about some ideas before we gather back together as a class. you move the pink, like axis, it kind of changes where it's at too. Like if you just like move it up and down, so you can kind of see where it rotates about. There's different factors going on there.
What's really cool is you can actually, if you want to move the whole thing, it will move the transformation. Yeah, so you can play around with that a little bit, kind of get an idea of how these transformations are affected at different quantities. Yeah. Get, almost getting there?
Yep.
Okay.
This is rotating
Cool.
Is it?
Future reference.
Pay kind of special attention to the coordinates and what's happening with the coordinates when you do a certain type of transformation too. That'll help us further our knowledge with what kind of connections we made in the beginning of the lesson.
So what you can also do is drag these things right here, and then tinker around with how the transformations are affected as a result. Yeah, just keep an eye on what the coordinates are doing, and you know, how they're distanced from one another, all those things. I think you're specifying the points on here as examples.
Thank you.
I really like how you what kind of points we're paying attention. Really kind of makes you think about what's going on in that transformation. It's good work. It's great way to see.
What are you doing right here?
So you guys are all working really well right now individually, but if you do want to collaborate with your partners and kind of pair up, that's fine too. Kind of talk about what's going on and what you guys are noticing together. So,
What are you noticing as you continue to rotate that around?
Just looking at point A, it kind of stays, okay, the same distance from the origin, so it just makes a circle, well, it does make a circle actually.
Oh, okay, so,
I skipped
so point A is always, so we're assuming that, are we assuming that the origin is
Right here.
what is heavy rotated around? Okay.
I didn't know that it's good.
Now, if point A is equidistant at all times,
So kind of noticing
what
some
can we
you
say
guys
about the other
finding
points?
anything interesting.
When you
You
rotate
still
it
have
180
another
degrees, it's the
9
same
points
as
on it.
dilating by -1.
That's interesting.
focus on maybe focus on another point and see
That's
if
the only one so
you
far
notice
that I've
anything
found.
in terms of its distance
Found the same thing.
as you continue
So
to
what
rotate.
could you say about like the transformation in general? Like, is there anything that transformation's not like the others? You know how you said like you only found like 2 that are like preserve the features,
Right.
but what one have you noticed that is like kind of a lot different than everything else?
So you're doing
I think
dilation,
the
what are you noticing with
translation is
that?
very different.
I just got here.
You just got here, okay.
What,
Okay.
what about like the size and shape? What kind
Dilation
of
does
dilation kind
that.
of affects the size and shape? Do any of the other transformations affect that?
No.
No.
Size and shape, no.
Interesting. Interesting.
They're all different in their own way. They're all special.
What are you thinking about the dilation?
Well, the diamond times 2 is basically the corner times 2, so it's cool. So for like B, it's
Okay.
5, and then the corner for dilation of 2 would be 4 times, which is double the coordinates.
Okay. So how does that affect the different lengths and widths as well?
That part.
Okay. That'd be really cool to explore.
Josh,
Yeah. All right. Is everyone feeling good? Or okay. Looks like everyone's got some thoughts down. So what we're gonna do is we're gonna get back together and we're gonna maybe jot some other thoughts down that you guys noticed. So what else stands out to you guys? What are you thinking?
Well, we were talking about how dilation is different than the rest of them.
Okay.
And I was looking at what I noticed about like rotation and translation and reflection. When you are trying to find the new points for those, you're like adding or subtracting, but when you're finding the new points when you're doing a dilation, you're multiplying.
Okay.
That's very interesting. I like that.
All right. Bear with me. Okay, so dilation. There we go. All
So
right.
dilation was kind of the one that stood out to you guys that was different than the others,
Mhm.
and that was because of the defining properties of what? Did you guys say was the defining properties that affected?
You talk
I
about
mean, it
multiplication.
affects, it affects the size and you use multiplication.
Size and shape?
instead of- Yes.
So is there anything that you guys have, pulling from your background knowledge here, is there another word that kind of reflects size and shape that we can use to describe size and shape? So if two, say are two Fs, we rotated it 90 degrees,
Mhm.
and they had the same size and the same shape after the rotation, is there another word that you guys know that means the same thing?
It's a relationship.
Congruent.
Like some.
Oh, what was that?
What did you say?
Congruent.
Congruent, interesting. So if we know that congruent is another way to say size and shape, what transformations can we say provided some congruency?
Reflection, translation, and rotation.
Nice.
Okay. You said reflection? Rotation. Now, what was that last one you said?
Translation.
Okay. So, what about, where does that leave us with dilation? Do you guys have any thoughts as to how dilation seemingly seems pretty different? Seems we can't really get congruency from that. So, what do you guys notice? What are you thinking? Is there another sort of term?
Seems like it would be proportional.
Proportional, okay.
Nice. I like that terminology you used there.
I was
Proportional.
gonna say similar.
Similar, yeah.
Similar, okay.
Nice.
So proportional or similar. Okay, I like the varying terms there. I think they both fit very nicely.
All right.
All right. Any other last minute thoughts?
Good job.
Okay, cool.
So the rest of it was just going to be, you guys are gonna use, it was like a worksheet, and they're gonna explore similarity and congruence between two
Mhm.
triangles and how that affects it.
Awesome.
Cool.
Good job.
Perfect.
That was great, you guys.
We also have some cool tasks as well, such as like designing your own logo.
Oh, that was the extension.
BD as the extension, yeah. So that would be something you would hypothetically explore afterwards as well.
They're multiple at once, I would say.
Yeah,
All right.
the camera's still going.
Yeah, I was gonna,
Turn it off, yes.
Should just be able to press the stop button,
yeah, so this one?
the red one.